So for do now number 1, we want to write a 2-column proof. Again, 2-column proof means that we need statements and reasons. And again, the first thing that's always going into your proof is your given. So we have line M is perpendicular to line P, and again, that is because it is given. So again, let's think about what's special about perpendicular lines. Perpendicular lines intersect to form right angles. And I want to prove that angle 1 is congruent to angle 2. So that's going to be this angle here and that angle there. So again, the first thing I'm going to use is definition of perpendicular lines. And again, that's perpendicular lines intersect to form right angles. So right now I can tell you that angle 1 and angle 2 are right angles. And the reason that that is because of definition of perpendicular lines. Okay, and now the next thing I can tell you is exactly what I want to prove. I can tell you that angle 1 is congruent to angle 2, and the reason that angle 1 is congruent to angle 2 is because right angles are congruent. Okay, and it's as simple as that. So for 3-2, we're going to talk about proving triangles congruent. And you're going to have a quiz after section 3-4. Okay, and for this particular section, what we're going to do is we're going to take some of the concepts that we learned in the last section and now apply them to proving triangles congruent. So congruent triangles, by definition, those are triangles that have the same size and shape. Okay, and what this means is that all corresponding parts, angles and sides, are congruent. When triangles are congruent, we can write a congruency statement. So if you look at the picture of the two triangles below, I can say that triangle ABC is congruent to triangle DEF. And again, notice that these have 2 hash marks, those have 2 hash marks. That means that AB is congruent to DE. This has 1 hash mark, that has 1 hash mark. So BC is congruent to EF. And then the 3 hash marks would be congruent to the 3 hash marks. So AC is going to be congruent to DF. Same thing's going to happen with your angles. The 1 hash congruent to the 1 hash. So angle B is congruent to angle D. 3 hashes, angle A is congruent to angle D. And then 2 hash and 2 hash, that means that angle C is congruent to angle F. So this is a statement that we're going to use inside of our triangle proofs a lot. CPCTC. What does that stand for? Corresponding parts of congruent triangles are congruent. So basically everything that I just said in terms of which side was congruent to which side and which angle was congruent to which angle is because of CPCTC. Corresponding parts of congruent triangles are congruent. Okay, so for question number 1, it says list all congruent angles and sides. Given the congruency statement, triangle JKL is congruent to triangle PQR. You're not given a picture here. I would absolutely 100% draw a picture because what letter corresponds to what letter is going to matter. So I'm just going to, any old triangle is going to be fine. So I'm going to call that JKL. So when I labeled that, I started on this bottom left, and then I went up to the top, and then I went down over here. So when I draw my second triangle, I'm going to do the same exact thing. So P, Q, R. So now I have a visual, and I can tell you which angles and which sides are congruent now. So let's start with the angles. And it doesn't matter which pair you call, pair 1, pair 2, so on and so forth. So one pair, angle J, is going to be congruent to angle P. Again, notice J was the first letter and P was the first letter. So angle J is congruent to angle P. Second one, I'll do L. L is going to be congruent to R. L is congruent to angle R. And then our last one, K, is going to be congruent to angle Q. Okay, in terms of our sides, I'm going to say JL is going to be congruent to PR. That's one pair. Again, it absolutely matters. If I take one triangle and place it on top of the other, the ones that correspond are the sides that land on top of each other. So KL and QR. And then our last pair is going to be KJ and QP. So corresponding parts of congruent triangles are congruent. Okay, now this time you are going to be given a picture, but now look at the difference between the picture that I just drew. They were facing in the same exact direction. I labeled them in the same order, so they looked exactly the same, and it was very straightforward. Here, that's not the case. So now again, you're going to have to go by, again, the order that your letters are written in the triangle statement, in the congruency statement. So given angle KPM, triangle KPM is congruent to triangle AYC, complete each of the following statements. Okay, and in the end, we're going to have to talk about all of our angles and triangles and things of that nature. So the easiest thing to do is do the angles first. How? I'm going to go by the order in which they're written. So K is the first angle and A is the first angle. So K is congruent to A. Again, I'm going to fill in everything down below that they're asking me for in a second. I'm going to mark everything off first just to make my life easier. My second letter is P. The second letter is Y. That means P is congruent to Y. And then my last letter is M and my last letter is C. That means M is congruent to C. So now I have all my angles that are congruent. So now I'm going to go ahead and mark off sides. So for my sides, I'm going to pick anywhere to start. I'm going to pick KP. Okay, notice KP, that connects the angle that has one hash mark to two hash marks. So if I go into my picture on my right-hand side, again, I'm looking for the angle with one hash mark, which is down here, and two hash marks, which is up here. So that side that makes is going to be YA. Okay, again, I'll come over to my left-hand triangle and I'm going to do this PM next. So PM connects the angles with two hash marks to three hash marks. And again, if I go over to my right-hand picture, if I look for the side that's connecting the two hash marks to the three hash marks, it's up there. So lastly, that's going to leave this side KM, which is 1 to 3, and CA, which again is 1 to 3 in terms of the angles there. And now I can fill in all my pieces here. So KM is the side that has three hash marks. So when I look at my other triangle, the side that has three hash marks is CA. CY has two hash marks. Looking in my left-hand triangle, the side with two hash marks now is PM. And then PK has one hash mark, and that's going to correspond to the other triangle that has one hash mark, which would be YA. Angle Y has two hash marks going through it. The angle that has two hash marks going through it in the left-hand triangle is angle P. Angle K has one hash mark. In the right-hand triangle, the angle that has one hash mark going through it is angle A. Now they're going to get fancy in part F. They're asking you about ACY. Again, if you trace ACY, let me do a different color here. ACY, that's really this angle C with the three hash marks through it. So again, I want to find the three hash marks on my left-hand triangle, which is here. And again, the angle that's formed there is here. And again, you just need to be careful. A and Y. A had the one hash mark going through it. So on the other side, when I start to write the measure of my angle, when I start to write my letters of my angle, I'm going to start with the one hash mark. That has the one hash mark, so that's going to be angle KMP. Okay, and again, same thing when I go to talk about my triangles that are congruent. My picture's getting messy here. Hey, I have angle MPK. So when I write my congruency statement there, I have to, again, write it in the order of which one of those angles corresponds to which angle. So angle M corresponds to angle C. So C is going to be my first letter. P, two hash marks, corresponds to Y. Okay, and then by process of elimination, K is going to go to A. Okay, or again, one hash mark to one hash mark. So again, same thing is going to happen if I change the order of my letters. Okay, this one that I just wrote up here, CYA, is the same exact triangle as triangle YAC, only again, we have to write it in the order that things correspond to. So we're going to do the same thing. Y has 2 hash marks going through it. And the other triangle, P is the angle that has 2 hash marks going through it. A has 1 hash mark. K corresponds to that. And then C has the 3 hash marks. So M is going to be your other angle, your last letter that's going to be part of that triangle there. So you just have to make sure that you are writing things again in the order that they correspond to. Okay, so we're going to have 5 ways to prove triangles congruent. Okay, and we're going to abbreviate them using all these letters that you see on the left-hand side. And I'll show you what it's going to look like in the picture on the right-hand side. So the first way that we're going to have to prove triangles congruent is something called side, side, side. Okay, and what's going to happen here is you need 3 pairs of congruent sides. So that might look like this one congruent to this congruent to that, this one congruent to that one. So that's what it would look like if you had 2 triangles congruent by side, side, side. The next one, side angle side, you would have 2 sides and an included angle. So what this is going to look like, I'm going to pick out any 2 sides of the triangle first. So I'm going to say that one and then that one. This part is important. The included angle is the angle that's formed by the 2 sides that you have marked congruent. So in other words, if I trace the sides that I have marked congruent, that's the angle that's formed. That's the included angle. That's the included angle. It can't be any other angle. So I have side, angle, side. For the next one, for angle, side, angle, you have to have 2 angles and the included side. So this time we're going to do the exact opposite of what we did above. So this time I'm going to mark off any 2 angles. So how about this one, and then that one, and that one. The included side would be the side that connects the 2 congruent angles. So in other words, this side right here and that side right there. Okay, so those would be that would be your included side for angle, side, angle. Okay, for angle, angle, side, you have to have 2 angles and a side opposite them. So that would be, again, if I choose any 2 angles, okay, I can't do the included side now. So I can't do this side, can't do that side. That's the included side. Get rid of that, get rid of that. So I need to do a side that's opposite one of the angles. So how about directly opposite the one with 2 hash marks? If I go directly opposite, that's going to be this side here. Directly opposite, it would be that side there. Okay, so that would be angle, side, angle. I also could have done, just so you know, I could have gone in the opposite direction. So I could have gone opposite angle 1. And then I'd have to go opposite angle 1 there. So again, that's angle, angle, side. And hypotenuse leg, obviously you have to have a right triangle because a right triangle is the only time that you have a hypotenuse. And to prove hypotenuse leg, you need the hypotenuse and any one leg of the right triangle. And again, the hypotenuse is always the side directly opposite the right angle. So I have to have that and I have to have that. That gives me my hypotenuse. And then 1 leg. Again, it doesn't matter which leg that you use. Your legs are the sides that make up the right angle. So I'm going to say this one and this one. Okay, so that's hypotenuse leg. Again, if I decided I didn't want to use that leg, I most certainly could have used this leg here and that leg there. Okay. So some very common things to look for when we're talking about congruency in triangles. You should always look for vertical angles. Vertical angles are going to come up a lot and they're going to help you out big time. So in this picture, I would have this angle congruent to that angle. Again, just keep in mind, you can't call that angle L. It would be angle KLJ and angle NLM. You have to use 3 letters there. And then also the reflexive property. Again, if they have a common side, the reflexive property is going to come in handy a lot here also. So the side that these 2 triangles share over here would be AC. So AC would be congruent to AC for the reflexive property. Okay, so for our last slide here, we're just going to state why these triangles are congruent. There's going to be by one of the things that we just spoke about above. The only thing that you can assume if it's not marked, you can only assume the vertical angles or the reflexive property, just like we just spoke about. Okay, so we'll see why these triangles are going to be congruent. So if I look at 3, I have an angle, and a side. That is not the included side. So that one's going to be angle, side. 4, we'll go to the right. This time I only have one thing marked off. Okay, so one other thing that I can do here, again, these triangles share a side. It's right here. And the side that they share, I can use the reflexive property to say that that is congruent. And now if I look at my blue triangle and Scout, shh, no whining. Okay, and my red triangle, I have the hypotenuse, and one leg. So that one's going to be hypotenuse leg. Okay, so for my next one, for number 5, I have 2 sides marked off, and the only other thing that I can assume here is those vertical angles, and this would be angle, side, side. This is called the donkey theorem. Okay, angle, side, side. Use your imagination. What does that spell? Angle, side, side. You cannot use angle, side, side. That's called the donkey theorem. That's why there's a donkey on the front of your classwork packet. Okay, so this you cannot prove congruent. So they're not congruent. Okay, for number 6, I have one pair of sides and one angle that's congruent. I have no vertical angles in that picture, and they share no common side or no common angle. So these cannot be proved congruent by what's given. Okay, for 7, I have one pair of sides and one angle. And again, these 2 triangles share a side. So that shared side, again, we can use the reflexive property on. So that would be side, angle, side. That angle, again, is formed by your 2 congruent sides. So that would be side, angle, side. For 8, we have 2 sides that are marked off already. And again, if I need my 3rd side, again, I can use the reflexive property on that piece there. So that I have 1, 2, 3 sides congruent to 1, 2, 3 sides. That would be side, side, side. For number 9, I have, again, 2 right triangles, and I know that because of the little box in the corner here. And again, I have the sides marked opposite the right angle. So that's my hypotenuse of each one of those triangles. And then those 2 sides are legs. So that one's going to be hypotenuse leg. In 10, again, I only have 2 things marked off. I have a side and I have an angle. They don't share any common sides this time, but they do have a pair of vertical angles, which I can assume from the picture are congruent. So again, this time I have an angle, and then a side. So that's angle, angle, side. Again, that side is not the included side. It's not angle, side, angle, because the side would have to connect to the 2 congruent angles, which that does not. Number 11, you have one pair of congruent angles here, and the only other thing that I can assume is that side is congruent to itself by the reflexive property, and there's no such thing as angle side. Okay, so these 2 are going to not be congruent, so they're not congruent here. And then in 12, again, I have this side congruent to this side, and this one congruent to this one. And again, the only other thing that I can assume there is that pair of vertical angles. And here we are with our donkey theorem again. Angle, side, side, ASS. You cannot prove 2 triangles congruent by the donkey theorem. Okay, so the answer is no there.